Alright, we're going to look at Chapter 6, Section 2. This section is all about isosceles triangles. The first thing, let's review what an isosceles triangle is. Isosceles triangles have at least two sides of equal length. So if you notice at this one, this side is equal to this side. A couple other vocabulary terms is the angle between the congruent sides is called the vertex angle, and the other two angles are called base angles. So if you're looking at this, we have the congruent side, we have the vertex with the vertex angle between the two congruent sides, and then down here we have what we call the base angle. Now the base angles are not always going to be on the bottom. You're going to have to look for the congruent sides, and the side that is not congruent is the one that we call the base side, and that would have the base angles. It would be a good idea to put this drawing in your notes and label the congruent sides, the vertex angle, and the base angles. Okay, the first theorem that is in this section is the isosceles triangle symmetry theorem. So right here I have an isosceles triangle, and in this isosceles triangle, this side right here is congruent to this side right here. This is the vertex angle. So right there we have the vertex angle. So it says the line containing the bisector of the vertex angle is also the symmetry line of the triangle. So remember that whenever you're doing a symmetry line, it's cutting the triangle into two congruent parts. So I have this congruent side here, this congruent side, I have this angle, and then it would cut the base into two equal pieces. So that's the isosceles triangle symmetry theorem. The second idea we have is the isosceles triangle coincident theorem. And what this means is that if you have an isosceles triangle and you draw in a line that bisects the vertex angle and also hits the midpoint of the base, then this line bisects the vertex angle, is perpendicular to the base, it bisects the base, and it's also the median to the base. So in an isosceles triangle, all of these things are represented by this one line. And it cuts this isosceles triangle into two congruent right triangles. So this would also be your line of symmetry. So this line represents a lot of different things. If you don't know what a median of a triangle is, it's the segment that connects the vertex to the midpoint of the opposite side. In an isosceles triangle, all of these other things coincide with the median, but if you were looking at a scalene triangle, that would not be the case. So remember, in this section, we're only talking about isosceles triangles. Okay, so this is a sketch that you worked on today in Geometry Sketchpad. And if you notice in this sketch, what I have is I have two congruent sides. So this side and this side are congruent. And what I was hoping you would notice whenever we were working on this, and whenever I asked you to look at the angle measures, I would hope you would notice that this angle right here is congruent to this angle right here. Now this one I have 1/100 of a degree off. 1/100 of a degree is not enough to be concerned about. But what I wanted you to see is okay, so I have congruent sides here, and then I have the angles opposite them are also congruent. So that is the isosceles triangle base angles theorem. If the sides of a triangle are congruent, then the angles that are opposite. So whenever I say angles that are opposite, this angle is opposite this side, and this angle is opposite that side. So whenever we're looking at this, if the sides are congruent, the angles that are opposite those sides are also congruent. Okay, and this is the other one that I asked you to draw. I asked you to draw just any old triangle. My triangle is scalene. And I wanted you to look at the relationships between the different sides and the angles that are there. Now, as I was walking around, I didn't really see anyone that caught on to what I was trying to get you to see on this triangle. But if you notice, this is my largest angle right here. And also, let's check the measures just to be sure. This one is about 31, this one's 27, and this one's 122 about. Now I want you to look at the side that is opposite this large angle. Okay, so that is the largest angle, and if you compare the measurements of the side, the longest side is opposite the largest angle. So if you look at that, angle C is my largest angle, and then if I compare the sides, the longest side is across from angle C. Well, and it continues to work that way also. So let's look at my smallest angle, which is this one, CAB. So if I look at CAB, that's my smallest angle. If I look over here at the side opposite that angle, if you compare it to the other side measures, the smallest side is opposite the smallest angle. So that was what I was trying to get you to see whenever we were doing the activity where you were supposed to draw your own triangle. I saw a lot of people who said that the sides aren't congruent since the angles are congruent, but I did not see anyone who caught on to the idea that if I have a scalene triangle, the longest side is opposite the biggest angle, the shortest side is opposite the smallest angle, and then of course we have angle B, which is the angle in the middle, and the side opposite angle B is the side whose measure is in the middle. So it would allow me to put these sides in order from least to greatest. If I only knew the angle measures, I could tell you which was the longest side, I could tell you which was the shortest side, and then that would leave the third one for the middle. I could also, if I knew the side measures, tell you which angle was the biggest, because the biggest angle is opposite the longest side. And this is one of the really important concepts in this. There are two in this section. One is the isosceles base angle theorem, and the other one is this unequal sides theorem. So whenever you finish with your notes, I want you to go and answer the questions in the assignment.